last one, then tomorrow's pretty much a review day. We're going to be working in class. I can apply properties of exponents, algebraic with rational exponents. So if we were thinking of writing this out to explain, 4 to the 5th means how many 4s? 5 4s, right? This is written as a power, 4 to the 5th, and that means I have 5 4s, and 4 to the 3rd means that I would have my base of 4 repeatedly multiplied 3 times. And if I was looking at this problem and I wanted to simplify, 4 over 4 is 1, another 4 over 4 is 1, and another 4 divided by 4 is 1, which leaves me with 4 times 4, or 4 to the 2nd. So if we are looking at division, opposite of multiplication, our shortcut probably is to do what with both exponents? We are going to subtract when it is division. So when dividing powers with the same base, this is really important. Make sure you have with the same base. So I have sometimes that people are thinking that it doesn't matter what the base is. The base is not changing. So some of you in your homework quiz, you told me that you were, the question was when you multiply, what are you doing? You said you were multiplying the exponent. So just be really careful. Here you are subtracting when we look at our problem. And if you think of this would have been 4 to the 5 minus 3, and 5 minus 3 does give us 2. And you don't have to show that subtraction. I assume that you can just do that. But if you need to, you should write it down. Like on this first one for me, if I was looking at it for some of you that struggle with fractions, you might want to write, we have x, and we're going to take 5 halves, right, minus 2. Well, 2 is really 2 over 1, right? So what's my common denominator of those two? That's really going to be x. 5 over 2 minus 2 over 1 is the same as what? 4 over 2. So 5 minus 4 gives me x to the 1 half. So in this next one, we're going to do our subtraction. I'm going to take m, and I'm going to have 2 minus 5. I'm going to have n to the 4 minus 3. So if I am doing that, that's going to give me an answer of m to the negative 3 and n to the first. But we cannot leave our answer in this form anytime it says simplify. So anytime we are trying to simplify, we want to rewrite that then, and we would have n to the first in our numerator, or you could just write it as n, right? And in my denominator, if I'm thinking of this as over 1, when I move that m down, it will become m to the 3rd. Now, usually in algebra, I will also talk about the fact that could we have done this differently? And where is your larger power, your larger exponent? So if you look at this problem, the other way that I'll have students do this is they'll say, oh, m is larger in the denominator. So I'm going to take 5 minus 2. Put your calculator down, you don't need it for this. So we're looking at this point. So I would like you to write this down for your notes. So 5 minus 2, right? And then in our numerator, going with 4 minus 3. Does it give us the correct answer? N to the first and m to the 3rd in the denominator. And I don't have to remember if it's negative exponents moving it. If I look at where the larger power is, so 5 was larger and 4 was larger, so I'm going to put the 5, m to the 5 minus 2 in our denominator, n to the 4 minus 3. And get the same answer both ways. I don't care if you do it this way or if you do it this way, but just make sure that you kind of are sure you're placing your base in the correct spot. So we take a look at these next ones on the top of the next page, on the top of page 11 in your notes. So if we are subtracting y to the 3/4, and we're subtracting a half, but a half is how many fourths? 2/4. So you might want to rewrite 1/2, right, as 2/4. So that we should get y in this case, Elena, to what power? Y to the 1/4. If we are looking at that next one, we're going to have d to the 7/2, and we are subtracting 3. 3 is how many halves? So it is 6 over 2, right? So a lot of times if you can rewrite those with that common denominator, so that now if we are looking at that, Jack, I should have d to the 1/2. I would like you to try those next ones. First one, Josie, what'd you do?
I would change to the second minus 7, which is going to be, and then j to the second minus 5, and then keep it on the bottom.
So we went and had j to the 5th and j to the a to the 5th, excuse me, and j to the -3, so the j moves to the denominator, okay? Sorry, if you're explaining how you did this one.
A to the -3rd minus 5, it's just a to the -8, b to the 7 minus 2, which is b to the 5th, and you take a and put it on the bottom.
So because we had a to the -8 and b to the 5th, the a has to move to our Usually if you start with lowercase, kind of keep them lowercase. This last one, if I'm looking at it, the x to the 4s, those cancel, right? Someone said, oh, that's x to the 0. X to the 0 is still 1, right? X to the 4 over x to the 4 is 1. If I'm subtracting my y powers, if you were going to tell me how I'm subtracting those, Evie, we have what?
Y to the -6.
So -1 minus what?
-5.
-5. And our z powers, Dylan, is going to be what?
Z to the 7th.
Because we took 8 minus 1. So the most common mistake that people are making is with the y's. So that's why I kind of wanted to look at this one. If you are taking -1 and you are subtracting a -5, that becomes y to the -1. Subtraction changes to add the opposite of -5, which is 5. And I agree, the z is going to be 7. But the y is not going to be -6. It is going to be y to the 4th and z to the 7th. Okay? So again, as you do your homework, my hint is check your work as you are going. So the next part down in your notes kind of states the rule. And it just says if you have a fraction raised to that power, you have to raise each thing to the power. So kind of like what we were doing with our powers to a powers and when we were multiplying, this means we have to multiply here. So we are taking z to the 2/3 times 3, and then we're taking 5 to the 3rd. 2/3 times 3, that's the same as 3 over 1 if you're thinking about that. That becomes 6 over 3, which is just z to the 2nd. Okay? So notice in the rule for raising powers, it says that a and b cannot be 0. A cannot be 0 and b cannot be 0. And n is a rational number. The reason that b can never be 0 or a is if you take the reciprocals of those, or you do, and you divide by 0, what's any number divided by 0? Any number divided by 0 is always undefined. So the reason they always say that in your rules, that you will see that, is because this is always an undefined number. And we are doing these rules for defined numbers. So that's why you always see that as part of the rules. Okay? So, if we have negative exponents and you have something in the fraction, that just means you take the reciprocal of the whole thing. So a lot of times on the last one, some of you didn't write down that word reciprocal. Remember, negative exponent just means find the reciprocal. So when we are looking at this problem, I want you to notice the first step that they did in this example is they changed this to a +3 by taking the reciprocal of our 2x to the 6th and y to the 4th. So when you take the reciprocal of that, then you are taking each thing to a power, which means now you're applying all your rules today. So 4 times 3 gives us 12. Here you should have taken 2 to the 3rd, that's how they got that, and then they multiplied 6 and 3 to get the 18. So 2 to the 3rd, that's how they got the 8. Y to the 12, x to the 18th. We have no negative exponents. What some of you did on your last quiz, that homework quiz, you left variables in the numerator and denominator. You can't have an x on the top and the bottom. You cannot have 2 x's being multiplied. Simplify means I only want to see one base of y, I want to see one base of x, right? I don't want to see multiples of them, and no negative exponents. So, I would like you to take a look at these. The first one, as you are doing this, so we are going to simplify that first one. Maria, if you were telling me what to do, what would we do? 3 minus 10, which is going to give us an answer, Lainey, of y to the -7. And Taylor, if I'm simplifying, I'd rewrite it as 1 over y to the 7. Okay? if I'm looking, Cassandra, at this next one, what are you going to do first to start off? So 1/3 times 3, and in our denominator, what am I going to be doing, Liz? 3 to the 3rd power. So 3 times 3 would be different. So in this case, 3 to the 3rd, we are looking at 27. And in our numerator, Gavin, I should have just x. Someone said, what if I put x to the 1st? X to the 1st would not be wrong, but you can leave it as just x over 27. Okay? If I'm looking at that next one, Brecken, what do you want to do first? That m n to the negative 3.
You want to make exponent columns and to the over.
So you're going to rewrite it and go m to the negative 3 over n to the negative 3 first. Once I do that, Jacob, what do I want to do? Because I cannot have negative exponents. Okay. So what do I do? So in the numerator, I'll end up with n to the 3rd, and in the denominator, n to the 3rd. Okay. So this next one, my hint is, and I probably would have done it in this one too, where Brecken had that one, I probably would have started the problem and said, you know what, I'm going to make this a positive exponent first, and put n over m, and make this a positive 3. And that is definitely what we want to do in this problem. So we want to start with putting a positive 4. So when I put the positive 4, tell me what I'm going to be writing, Whitney.
5y to the 4 over 3x.
Okay, so now as we are simplifying, tell me what am I going to be doing next as I'm looking at that pattern.
Then you distribute the exponent to the, so you have 5 to the 4 divided to the 16.
Okay, and we're taking the 16th. Okay, stop there. And if I'm looking at my denominator, what am I going to do on? Really close. Really common mistake, really close. We have to have the y, or the 3 has to also be to the 4th. So it's easy to always multiply those and kind of forget about those 5s and 4s as we are looking at those. So when we are doing that, if we are multiplying those, so you might want your calculator for that. 5 to the 4th is 625. And if we are looking at 3 to the 4th, that one maybe not so much. 1, right? Y to the 16th and x to the 8th. Okay? Now, tomorrow in class, you'll see that next part, that 4b. So we're going to kind of be putting all your rules down. So you notice it has this part where all the rules are listed. And then you're really going to be working on that review. So that's all there is for tomorrow and getting ready for the quiz. Yeah?
There's integer as a base for an exponent. Like at what point do you want to just keep it as an exponent instead of a number? Or do you want to
usually, unless it says keep it as a power, you're going to multiply this out and tell me 3. So when you look at your assignment today, right? Most of these just say simplify. That means if you have, like in 23, the most common mistake in 23 is people go, oh, what do I do with 12 divided by 4? 12 divided by 4 is 3. You're done. There's no exponents. When I look at this 5 and 10 here and 16, that's like 5 goes into 5 once and 5 goes into 10 twice. And then I am moving my variables around if I need to. But if those numbers are not raised to a power, you can simplify. So you are doing 13 to 23 odd. Then you go from 33 to 47 odd. 61 to 67 odd, and 71 to 77 odd.